the much higher density, so you're storing what 20, 30 gigabytes on a single medium, whereas CD-ROM is only up to 700 megabytes back in those days. Yep.
And then after the program, so how do you have instructions that say not to concern ourselves with the top part?
What?
Are you on the control?
On the control?
The program.
The homework?
I'm pretty sure you have the homework.
Yeah, we're going to talk about it today.
Well, I mean, you say you're not going to talk about the handling of getting the input from the command line?
Yeah, it's already done. That part is done already. So the input part is already done. So what I will do today is something that I did with the earlier class too. You guys have the benefit of, I made all the mistakes in the morning already. So you guys get the smooth presentation, right? Well, as smooth as I can get it, right? So what we'll do today is we'll talk about the homework assignment first. It's find maximum. So it's already here. It is under control structures because that's really a homework assignment for control structures. So when you click it, it will present to you a zip file, and you have to unzip it first, and then it will give you a main.cpp file, which is going to be your source code. You have to start with that one. In the previous class, some people, I was doing everything in Linux using the command line, and then some people did not they wanted to use code blocks in Windows, and want me to kind of show them how to do it. So I can do it also here. Well, I mean, just to be fair, I mean, I could also just replay the video from the morning, but that would be boring for myself, and for that reason alone, I'm not gonna do it.
You don't find it awkward to listen to yourself either? That's
exactly. Awkward. So I have to walk outside when you guys are here.
Is that what I sound like?
Yeah, but some politicians like to listen to themselves.
Oh, most do.
And Britney Spears cannot even listen to herself because it's not her actually singing the song, right?
She sounds awful. Have you heard her without?
Well, I heard pretty good.
No. Without all the bells and whistles on her. Have you heard her sing?
I want to even try to hear what the bells and whistles.
I didn't want you. I'm just saying.
I know, I'm just joking.
Some of the other artists, like in the past decades, they can actually sing off stage. Surprisingly, some of the actors, this is going to take a while. Yeah, if you watch even Voyager, okay, if you watch Voyager, the Doctor, the geeky guy, who plays the Doctor, state the nature of your emergency, right? He's actually a very good singer. Yeah, some of the supporting actors and actresses are actually very talented. All right, so we are in Windows in Linux. Okay, this is actually Windows running in an emulator in Linux, and it is still faster than me booting up from in Windows from the hard drive, which I really don't understand. And this is also going through my USB 2.0 connection to my external hard drive. It is perplexing. So we'll go ahead and start with the browser, go to the website. So this is the entire workflow that you need to know to get the homework done if you decide to use code blocks in Windows. So we'll go to the Moodle website, log in, grab that zip file, and then go through the entire process of how to write the program and how to debug it in Windows. And let's see, is it getting recorded? Yep. Okay, so everything is being recorded, including this part, because the virtualization, the virtual machine is actually inside Linux, so it's also getting recorded. All right, so once we log in, we go to this class website, usual stuff, and then go to control structures. Go to the bottom part of that page, and you will find the homework assignment called Find Maximum. The first thing you have to do is to download a zip file. So you just go ahead and click it. It downloads. In Windows, it automatically opens it using Windows Explorer, which is fine. All right. So this will open it, and inside the zip file is a folder called control, and inside that particular folder are two files. The second file, you can just go ahead and delete it or do nothing with it. It's an executable in 32-bit Linux, so for the most part, if you're using Windows, it's useless. The first file, which is a C++ source file, that is the file that you want. Okay, that is the file that you need. Okay, so at this point, if you plan to use code blocks to do your homework assignment, you don't want to double click it. Okay, this is not a good time to start it just yet. So what you want to do is to start code blocks. So I'm going to go ahead and start code blocks. And then you have to do like one or two things in code blocks first before you can incorporate the code that I have written so far. So in code blocks, what you want to do is to go to File, click New, and then Project, and start a console application project. And the rest, you can just take all the defaults. For the project title, call it Control, because that will also create the proper folder name for your project. So you better make sure that your project title is Control. And then click Next. Project with the same name already exists. Okay, yes, that's fine. Files may be overwritten. So I'm clicking yes here, but you would not see that screen, because if this is the first time you do this, it won't give you that screen, because I'm doing it again. This is the second time I do it. The rest of this should be fine. You want to have a debug configuration. The release configuration, you don't need it, but if you want to, that's okay too. And then click Finish. Project file already exists. Do I want to overwrite it? Yep, go ahead, because I'm just showing you guys how to do it in Windows using code blocks. And it gives you all kinds of warning messages. Overwrite the file, sure, yes, go ahead. All right. So if you do everything like this, code blocks will give you a hello world main.cpp, which is not what you want to use to start your program. Okay, so once you get your project up and running, then you go back to the zip file and double click on this one, which will show you in a different tab in code blocks the actual code that I want you to use to start with your program. So at this point, this is the code that I have already written. Do a Control A, select all, Control C to copy. Go back to the other side, Control A to select all, Control V to paste and overwrite. And now you have just copied my source code into a source file in code blocks. I could not figure out how to import a folder with a CPP file into code blocks, so this is the get around to do it. Okay, so now you can close the second tab. This tab is no longer useful. This one is not saved yet, because you can see the little asterisk symbol before the name. So you click save all, make sure you save all the files, and this is your starting point. Your code is going to be here. So okay, I know it's a little bit hard to see because it's all in gray, and it's actually easier on the projector. It says insert your code below this line, and then the second line or the line below that is insert your code above this line. In other words, you can write as many lines of code as you want, but they must be between these two lines. You can insert additional lines if you need. Okay? Are there any questions about where you're supposed to put your code? Okay. So by the time control gets here, by the time we get to line 42, line 43, 4 variables will be initialized already. Variables W, X, Y, and Z will all be initialized with integers that you specify on the command line. Your job is to examine those 4 variables, find the maximum of those 4, and then store the maximum in another variable called max, M-A-X. All the variables are declared already, so you don't have to do a single thing to declare variables. Your focus is just the logic to find the maximum and store that into the variable max. Are there any questions about the nature of what your program is supposed to do? Now, how you want to do it is entirely up to you. Okay, there are many ways to do this program. I wouldn't say any particular way is wrong as long as you get to the right answer. And this is not a competition of what is the shortest, most concise, or most convoluted way to get it done. As long as you get it done, it is still good. Okay, I will talk about how it is going to be graded later. Okay, The first part of this program, for those of you who are curious, you can read it, but you don't want to spend too much time on it. Okay, it is definitely involving a lot of concepts that we will introduce later in this semester, but not quite yet. So it will involve pointers, arrays, and stuff like that. And don't bother with that unless you're really, really curious. And only do that after you turn in your homework assignment. Yep.
Is that due next Wednesday?
Yes, it is due in a week. It is due in a week. Okay, so the way you run this program, especially with a debugger, is like this. Okay, you specify the 4 numbers on the command line itself. So it's not like an input file. It's not interactive. The program does not wait for you to enter a number. It's not using standard input. So the way you do it is you go to Project, and then you go to Set Programs Arguments. And over here, you can now specify when the target is debug, you want to specify program arguments to be the 4 numbers that you want to use for testing your program. Okay, so you can say 2, 4, 5, 7, for instance. Okay, and click OK, and this sets up code blocks to test your program with specifically those 4 numbers. Then you can run the program. Go to Debug and run the program, and it should run to completion and show you the result of the whole thing. And it obviously is really fast, and we couldn't quite see the result of the program, can we? Okay, let's see, is there a way to see that? Nope, there's no log of the output. It just says the program exited normally with a status of 0. Okay. Sorry?
No, I'm saying which is not very helpful.
I think you probably can use a run here to run it too. But this one does not give you the number. If you want to just run it without using the debugger, you have to go to Project again, go to Set Programs Arguments, but this time go to Release and specify the same thing. Okay, so 2, 4, 6, 7, doesn't matter, just give it 4 numbers to process. Click OK, and then go to Build and Run. So this time it says, it prints -2. The result is -2. Okay, so the maximum of 2, 4, 6, and 7 is -2. That's because the logic is missing, right? It's not doing a single thing. Max is uninitialized the way it is. So it can print any result here, and it's still, that's what it's supposed to do. Okay, it doesn't know what, max is supposed to be at this point. Okay, so your code or your job is to specify the logic that is necessary to find the maximum and store it into the variable max. Okay, your code doesn't need to print anything, so do not insert any printf or cout in your code, because it will interfere with my grading script. Because I'm going to grade this using a script, because I will give it many test cases. I'm not going to test everything by hand. I'm just going to run the script, and it will test your program. And you should do the same, okay? Because hand typing each and every single case is time consuming, and sometimes you will forget a particular, maybe tricky, test case. So what you want to do is, once you get the program up and running up to a certain point, and you say, I think I got it, okay? Then you have to come up with your own test cases to test your program, okay? To make sure that it works in all cases. It will find the maximum no matter which 4 numbers you give it, okay? So the way you test your program, the way I recommend that you set up your test is like this. You can go to Build first. Okay, I'm still in debug mode, so I'm gonna have to get out of the debug mode. No, I'm not debugging anymore. Okay, I have to click here first. Go to Abort, and then just it's not stopping. Pilot is currently in use. Okay, we'll do the scientific way to fix this problem. Stop it and restart, right? Okay, open recent project control. Okay, so now we got it back. Go to build and then just rebuild the whole thing. Make sure that it doesn't give you any error messages. So now go to a DOS prompt, okay? So to go to a DOS prompt, there are two ways to do it. You can go to the folder where the executable is first. So you navigate to your usual user folder, and then you go to Documents, My Documents. And then inside My Documents, you will find the folder. And then inside the folder, you will find bin as a subfolder. Inside bin, you will find debug. And this is where you want to open up a command prompt. Okay. So at this point, you can do a right click. And let's see, does it have a new command prompt here? Nope. There's no easy way to open up a command prompt at this
Did you say you're looking for new?
Hmm?
It's down at the
No,
bottom.
it would have been new command prompt.
Oh, new.
New folder, shortcut, contact. There's no way to open a new command prompt when I'm in this folder. Okay, well, that's okay. No big deal. You just have to start CMD using the Windows Start button. And now we have a command prompt. Now you have to use CD to navigate to that folder, which is under Documents. And then Control, and then bin. Oh, wrong command, ls. Okay, go to Debug. And now we have the executable. The executable has the name of control.exe. So this is a good place. Okay, so next thing you want to do to test your program is you don't want to have to run this program manually every single time to test it, because you will probably have many test cases as well, just to make sure that your program works. So what you want to do is something that I have done here already. You can use Notepad, you can use any text editor for this purpose, but the point is you want to create a text file with an extension of .bat, is a batch file, and in the batch file you just basically write down all the test cases that you want to run your program through. So in this case, I have 4 individual test cases. Okay, so the first one tests, make sure that if the last number is the maximum, I can identify it. The second one is the first one, and then the second one, and then the third one. Okay, but you also have to account for cases where you have 2 duplicate numbers. So if you have 4, 2, 4, 1, then the answer is still 4. 4 is the maximum. Okay. So you have to make sure your program works for all of those cases, and you can have as many cases as you want. Once you have created this file, you save it, and you can close your Notepad. And from here on, to test your program, you just have to type test. Okay, it runs the batch file, and then the batch file will run all the test cases automatically. So this gives you a very quick and easy way to rerun the tests. Every time you make a change, you fix a problem, you rerun all the tests to double check to make sure that your program is still working correctly for all the cases. Because it is not uncommon that you might fix one problem, but introduce another problem. Okay, it happens all the time. According to IBM, for every bug that is fixed, people introduce like 0.8 of a bug. So as long as that number is less than 1, I think we should be happy, right? We should be glad it's less than 1. Because if for every bug that you fix, you introduce 1.1 bugs, that means the number of bugs in the program will only continue to increase as long as we keep fixing it. Which is not good, right? Well, with bad developers, people who are irresponsible, inexperienced, or both, okay, that is what you end up with. Okay, there are certain times, certain days in my previous job that I was tempted to tell someone, please don't come back to work. Yes, you're getting the salary regardless, but don't come to work. Because when you come to work, I have more work to do. Yeah, it is sad. I mean, everybody starts off that way, but most people pick it up and go, oh, okay, they ramp up the productivity over time. But some people never really develop the skill set and just keep doing the same thing over and over and over again. All right, so enough ranting. So this is a good way to debug your program because you don't have to retype a single thing. You just say test, okay, and it automatically run all the test cases again. Especially if you have, let's say, 20 or 30 test cases, this is a quick and easy way to double check everything. Are there any questions about the workflow? Now, what if your program doesn't work? What if it identifies, one of these cases is wrong, okay? It just doesn't work on one of these cases. So what you want to do at that point is to go back to code blocks. So go back to code blocks and put a breakpoint somewhere within your code. Change the arguments to reflect the one test case that it failed. Okay, make sure that you pick the one that it failed. Make sure it's in the debug mode, and then go ahead and run your program in debug mode so you can step through your code line by line, step by step, to try to figure out why does it make the wrong decision and did not identify the maximum correctly in that case. Okay, so you do the batch mode to quickly locate, okay, did it work on all the test cases? If it did not, then you go back into this debugger and only use it on the test cases where it failed to work. All right. So are there any questions about the workflow and also what you're supposed to do with this program? No questions? You have 1 week to work on it, so it is due next Wednesday at 9 a.m. I'm using the start time of the first. Oh no, it should be 10:30. So I'll change it to 10:30. Yep. You can use arrays, but you have to use W, X, Y, and Z. Those are the only integers that will be initialized with the numbers that are on the command line. So if you want to declare your own array and use an array to find the maximum, yep, go ahead. You can even use the array that is already initialized.
Okay, right? Like
There's already one here, but you have to know how to use it. Pint is not pint, it is lowercase p, uppercase I. It's a pointer to integers. So we haven't really quite gotten to pointers yet at this point. Yep.
Since you brought up this line, would you quickly say what's the difference between the asterisk makes it a pointer, right? But the bottom line has two asterisks.
Well, I'm not going to talk about it at this point because we are way ahead of time. This is like something that we should talk about close to the end of the semester. So I'm not going to talk about it. If you know what this means and you want to utilize what is already, initialized here and use it instead, go ahead. That's fine. But for the rest of the class, you probably just want to use conditional statements or ternary operators to get this done. Okay. There are so many ways to get this done. You can use a sequence of conditional statements to do it. You can use a sequence of ternary operators to do it. You can use structured conditional statements to do it. You can use conjunction within the conditions. You can also use, like this is a conditional statement inside another conditional statement inside another conditional statement to get this done. There are many, many, many ways to get this done. You just have to pick one way to do it. Right? Are there any questions about the assignment as far as what you need to do, the objective of your code is concerned? No questions? All right. If there are no questions, the next step is for me to explain how it is going to be graded. So this time I'm doing a slightly better job explaining, how the points are allocated. 5 points out of the 20 points of this particular homework assignment is allocated to just conformance to my instruction. Okay. Did you turn in a zip file or did you turn in just a C++ file? You're supposed to turn in a zip file. If you turn in a zip file, does it only contain a single folder control, or do I have to dig like 4 levels down to find control as a subfolder, as a subfolder? Does the folder contain the source file, which is main.cpp? Now you can have additional stuff in it. It doesn't bother me. So if it has, bin, debug, and all those, subfolders and extra items, like text files that you write to remind yourself how to get something done, or test cases and stuff like that, doesn't bother me. All I'm looking for is just main.cpp. Okay, it is not control.cpp. It is main.cpp in the folder control. Does the code that you insert print anything? You're not supposed to. Okay, so for those of you who really, really want to use printf or cout to debug your program, please remove all that code before you turn it in. Because if those printfs interferes with my grading script, I will mark it down. Okay? All right. What about the rest of the 20 points? What about the other 15 points out of the 20? Well, those are all test cases based. So if I give your program, let's say 15 test cases, and your program works on 14 out of the 15, you lose 1 point. That's basically what it is. So that means you really want to make sure that your program works and compiles. Because otherwise, those 15 points will be gone. You can turn in something like it is a zip file, it has a control folder, and it has main.cpp inside. That might get you 4 or 5 points, and that's it. Okay, so you definitely want to turn in something that works for the most part. All right? Yep. Sorry? I have not created that one. But that one really doesn't have a standard answer either. It's just, creating a folder, with a file, turning in with your name, before the, hello, and then your first name's world. So there's not much to disclose with that one. All right. Any questions about this one? No questions? Okay. So if there are no questions about this one, we'll go back and continue to talk about files. Okay. If anyone think of anything to ask, just ask me, before the end of the class. That's fine. Okay. So talking about files. This document is pretty much done. We were just talking about what files really are, and just about what we understand files, traditionally, if you ask a person who's taking a word processing file or an Excel class, and you ask that person what a file is, that person will give you a correct answer, but that's not the kind of files that we are dealing with here. In computer programming, especially in C and C++, the files that are always available to your programs are C-in or C-out, or standard in and standard out. The standard input file and the standard output file. In other words, in main, by the time you get to main, you are guaranteed that there is a conveyor belt that can potentially be feeding your program something to process. It's called standard input. Then there's always a conveyor belt already available to you that is going out of your program. So if you have any result to show somebody else or to store to some other your files, that conveyor belt is already available. It is called the standard output file. So standard in and standard out are always available by the time you get to main in a C and C++ program. So what we are doing next is to go revisit a program that we are very familiar with at this point. But in this case, I will go ahead and explain all the kind of little things of this program. We'll start with the first line. What is pound include bracket stdio.h close bracket? What does it really mean? What does it do? Why does it need to be here? That's the question. So the reason why this has to be here is because without this line, the compiler will compile everything all the way down to this line here. But when it gets to this line, the compiler will say, oh, I can see that in this context, printf is supposed to be a subroutine. It doesn't have a problem understanding that printf is a subroutine, but it has a problem of, oh, as a subroutine, what are supposed to be the arguments? Okay, because without anything telling the C compiler, printf is really just a subroutine. It doesn't know how it is supposed to be used. And without knowing how printf is supposed to be used, the compiler cannot do its job to make sure that you are in fact using printf in a correct way. Okay, so that's why without the pound include line, by the time we get to this line here, the compiler will say, I'm not sure how to use printf. Okay, you have to tell me what printf is supposed to do or how you're supposed to use printf. So that's why we have this line here, pound include stdio.h. stdio standard io.h is basically what we call a header file. A header file is not the same thing as what you're seeing here. It usually does not contain any logic of a program. It does not include the definition of a subroutine. Instead, it includes what we call the prototype of a subroutine. The prototype of a subroutine only tells you how you're supposed to use a subroutine as opposed to how a subroutine is actually implementing what it is supposed to do. Does everybody understand the difference between those two concepts? How to use something as opposed to how something is actually done. Think about driving a car, okay? If you need to drive a car, do you have to understand, how a gas engine works, the 4 cycles of combustion, all the variable valve timing thing that your Toyota is doing? No, you just need to know where to insert the ignition key, and in some cars you don't even need to do that. You just press the button, right? You need to know how to use the steering wheel. Do you need to understand all the different technologies of power assist steering, electric versus hydraulic and so on and so forth? No. So that's the same thing. A prototype is really just, turn the steering wheel to control the direction of the car. The actual implementation is, what kind of pump are we using? What kind of electric motor are we using? How do we do all the force feedback things so that you have a feel of your steering? Nope. None of that stuff is what you need to know. So a header file just includes the instruction to use the steering wheel, but not necessarily how it is implemented. Okay? And in C and C++, when you use a subroutine and you want to pass parameters, you always have to remember to use parentheses to surround the arguments. So in this case, we only have one single argument. The one single argument here is called a string, which is basically a sequence of characters. So this is a sequence of characters, and in C and C++, we use double quotes to indicate the beginning and also the end of that string. What if you want to use double quote itself as a part of the string to print? You have to use an escape character, and an escape character in C and C++, and also in Unix and Linux in general is the backslash character. Okay? So in this case, we have hello world, exclamation point, and then there's this kind of little string to backslash n thing. Backslash n is again, backslash is an escape character. But in this case, we're not escaping the letter n itself. Backslash n all by itself means the line feed character. Okay, it is n because it stands for new line. So that's why it's backslash n instead of line feed or carriage return. It is just give me a new line at this point. Yep. If you do not have a backslash n, it won't give you an end of line as the output of your program. Then your command prompt is going to appear right next to the output, which is going to be hello world, exclamation point, and then your command prompt. So that new line separates the output of this program from the next thing that you want to do on the command line. Yep.
Maybe you haven't read the notes all the way through yet, but what's a subroutine?
A subroutine is, you might know a subroutine as a function or as a procedure in a previous class.
Okay, a function.
Yeah, same thing as a function.
Okay.
Yeah, subroutine is a more generic name. Function is a specific name that C and C++ use. Java use that term. In Pascal, it's also known as a procedure. So all of those things refer to the same thing. All right. So the rest of this slide, or the rest of this document, just talks about stuff that we already know, like how to compile a program, how to link a program, and also how to run a program. So all of that stuff we have talked about already. And this part explains, the various parts of the program. It's exactly the same thing that I have talked about, like what is a header file and so on. So I'm not going to repeat all that stuff. Redirection is something that we talked about last time. In other words, by default, when you run a program, remember the 2 conveyor belts that are always available to any C and C++ programs, right? There's one conveyor belt feeding information into your program, and there's another conveyor belt to get your output out of your program. Redirection means instead of printing everything on the screen on the console, which is the default destination, you can now use redirection and say, oh, I don't want to display everything that is output. I want to store that into a file. So redirection allows you to do that. It is not a feature of C or C++. It is a feature of the shell of a particular environment, of an operating system. In the previous class, I also tried to explain what is the concept of a kernel and what is a shell. I mean, I keep using the term the shell or the command line interface. For the most part, a command line interface is a shell. Okay, a shell is just a much more generic name for that sort of a program, of a feature. Okay. Does someone want to explain what is a kernel in the context of operating systems?
That's a hardware interface.
Not quite. Yep, go ahead.
Kernel, part of like it's a C file that stems from start of the program. The thing,
That's
part of it that launches like the dash files.
That's one of the things that a kernel can do, is to start the execution of the program. Yes. Not necessarily. It can run batch files, but that's not that's not the main part of a kernel. Yep.
Kernel, I think, it's the software, it's the part of the operating system that basically provides the interaction between I/O devices and memory that gives all the other programs the ability to speak to the hardware. So it's like I would say the center of the operating system.
Okay. That's really close to what a kernel is. A kernel is basically the inner part of an operating system, but by itself, a kernel has no way of interacting with anyone. Okay, but it has everything available already. It can handle a hard drive. It has all the device drivers, or it has interface to all the device drivers. It knows how to allocate memory to programs. It knows how to start the execution of a program. It knows what to do when a program is misbehaving. Okay, so it has all of those core features already, but it doesn't do any type of interaction. Okay, so what do you do if you have a kernel? Your computer is working. Okay, but how useful is a computer if you cannot interact with your computer? Not exactly very useful. And I think that's why you mentioned the batch file concept, because you can use a batch file to do something useful on the computer without any interaction with a person. Okay? But the execution of a batch file is one of the features of a kernel, is it can do it. Okay? So, but what if I want to interact with a computer? What if I don't want to submit a batch job and wait until tomorrow to get the result of running a program? What if I want to interact? Like what I do regularly in this class. Okay, so let me just kind of show you, instead of just talk about it, I'm going to show you what I mean by that. Okay, in Windows, this is one way of interacting with the kernel of the operating system. Okay, I'm just going to type something, and when the program runs, it will give me something back just in text. Okay, nothing fancy. This is a shell. In Linux, we have something almost exactly the same, very similar. Is something like this. Okay, I type a command ls interactively, press the enter key, the program runs, and it gives me the content of the current working directory, and prints it out. That is a shell. Okay, so CMD in Windows is a shell. Bash, be born again shell, is, guess what? A shell. And there's also another interesting shell in Linux or Unix land. It's called C shell. It's literally the letter C and then shell. And the reason why it's called C shell is because the scripting language of C shell resembles the C programming language. And that's why it's called C shell. Now, there are many other types of shells too, like minimalist shells. There are different types too. But these are the two shells that are most commonly used in Unix land. So that's basically the shell versus the kernel of an operating system. But what about Windows? What about this? What about, I'm just going to close everything here. What about this part here? How do we call this? Well, in Windows we just call that Windows.
Oh.
It's the GUI part of the operating system, okay? But in Linux, it is called X window, and then on top of X window, we have other stuff too, like a desktop environment, a DE. So XFCE4 is a desktop environment that is sitting on top of a session manager, and then that would be sitting on top of the X window, which is the lowest level stuff for graphical user interface. So that's all stuff on top of a shell. It's really fancy stuff that is not 100% needed if you just want to do something useful. All right, so I'm closing that one and getting back to Linux here. So we talked about redirection. We also talked about piping in this class. Okay, we talked about how you can take the output of one program and use that as the input of another program. Okay. Now, when I talk about it, it sounds kind of abstract. If I draw this picture, I think everybody would go like, "Oh, so that's what you mean." Okay. So if you look at a process, a program in execution as a worker, you can have two programs working at the same time. Okay, basically two programs concurrently running, two processes that are running at the same time. As far as this program is concerned, it has its own input conveyor belt. Okay. And it has its own output conveyor belt, like so. And these two conveyor belts have standard names. In C and C++, but in C, this is called standard in. This is called standard out, std out. In C++, this is called C in, and this is called C out. Now, when you use the concept of a pipe, that means you are now connecting a process with another process. The output of the first process becomes the input of the second process. That means C out of this program becomes C in of the next program. That is the concept of a pipe. So instead of having to store the output of a program into a file first and then use that file to feed the next program, you can do it without any intermediate storage. You can just immediately take the output of one program and feed it to the next program to process.
Have that first program launch the second program.
If you want to, the first program does not launch the second program. In the case of Bash, if you say A and then vertical bar P, the shell itself is responsible to start both programs. In terms of operating systems, the way they do it, the piping concept, they have to use pipe as a system call and also dup as a system call as well, DUP. But in this class, we are not so concerned about all those low levels operating system stuff. But we do want to understand the concept of piping because it is a very useful concept in not only in programming but also to utilize Linux commands, because you can take the output of one command and feed it to the next one. I'll show you one particular example of how it is useful. Assuming you name your files using a standard Unix way of naming the files, you can now do a ls and pipe it to LWC. You see what I've just done? I take the output of ls, which shows me the content of the current working directory, to pipe it to WC, which is a word count program. So this shows me that I have 5 files in this folder. IDE? And IDE is an integrated in code blocks.
Yeah, how would you pipe something?
Oh, how to do piping in code blocks?
Yeah.
I would imagine you can go to project arguments and then specify a pipe at that point. I'm not 100% sure whether that works or not.
So we just have to switch over to command prompts if we're going to do piping, or we just have to switch over to command prompts if we're going to do piping.
If you want to run a program in a pipe environment, you can either do it in GDB itself, okay, because code blocks is just a dressed up version of the editor and GDB all kind of built in. So if you drop it to GDB, you can do it in GDB. Right. So that's the concept of piping. And in this case, I'm using the output of the Hello World program and feed it to the word count program. Okay, so basically the same concept as what I have just illustrated a little bit earlier. So that's it. I mean, that's the entire document to describe files in general. I think last time I talked about a very dangerous command that can wipe your entire hard drive, because you can look at the entire hard drive as a single file. Do you guys kind of vaguely remember that?
Yeah.
I think most people remember the dangerous stuff, but not necessarily the useful stuff, right? Okay, so in Unix or in Linux, if you are already logged in as root, doing a DD is, so you can do something like this. And that will wipe the entire drive. Okay, it will take a long time, but it will wipe the entire drive. Because in Linux, in Unix in general, you can look at an entire drive, not a partition, but the entire physical drive as one single file. In this case, /dev, which is a special folder, it contains all the devices. SDB usually refers to a hard drive that you attach to the system later on, like a USB thumb drive or an external hard drive. So this command will take IF, stands for input file. It will take /dev/random, which is an endless stream of random bytes. Okay, it will copy content from the infinite source of random bytes to the destination. OF stands for output file. In this case, the output file is corresponding to the entire hard drive. So you'll be filling up your entire hard drive with random bytes. It is a good thing to do when you're about to recycle your computer and you want to make sure that people cannot read the content of your hard drive. Not such a good idea if you still want that content on your hard drive. It makes recovery almost impossible. And guess what? The first thing it overwrites is what we call the master boot record, which keeps track of the boundary between all the partitions. So you lose all that first.
Yeah, even if you stop it, you're already back.
Yep. But that's Linux. Okay, everything is a file. Okay. To further illustrate a concept, let's take a look at this particular computer. What if you want to know, let's just say, how long this particular computer has been running, okay, the uptime of this computer, okay? One way to do it is to look at, what we call a proc. In this case, I think it is called, version doesn't do that. I think uptime will do it. Okay, so here's a special file, okay? It looks just like a regular file. You can do a cat, you can do an ls on this quote-unquote file. And the content doesn't seem to be anything that is really tricky, right? I mean, it just tells you the number of seconds that this computer has been, or this operating system has been running, okay? So I've been running this, since 9 o'clock in the morning. There are 3,600 seconds per hour. So that number is about right, okay? That's about right. But if I do it again, that number changes. So it's updated. It's updated all the time, right?
Shouldn't get less.
Sorry?
I said it shouldn't get less.
Well, yeah, we're still trying to perfect the time, traveling thing. So it's not quite done yet. But you can see this number keeps changing. If you run it again, it will change again. So what kind of file can be this smart, okay, to get itself updated all the time? Well, yeah, go ahead.
That's basically like accessing the network.
It's accessing the kernel. It is accessing the kernel. /proc is a special subfolder because everything inside /proc is not actually a file. It's not something that you store on a hard drive. Everything under /proc is a part of your machine, a part of your operating system. So in this case, uptime is accessing a counter that keeps track of how many seconds your computer has been up since the last time you rebooted the computer. Okay. In other words, every time I do a cat /proc/uptime, I'm not really reading anything from the hard drive. I'm not reading anything from any particular drive. I am actually directly asking the kernel, the innermost part of an operating system, and say, oh, tell me how long have you been up? And it will do the conversion into base 10, okay, because internally everything is in binary. So convert it into base 10 and present a number. There are other interesting files like that too. You can ask for CPU info, and it will give you a big, huge, dump of what type of processor I have installed, on this computer. So it identifies this as an i5-3470. It's running at 3.2 gigahertz. It has all of these bits or attributes and virtualization bits and all kinds of bits like that. And the physical address bus of the processor is 36 bits, and the virtual number of bits of the address bus is 48 bits, and so on and so forth. And once again, this is not reading from a file that is stored on the hard drive. I am directly interacting with the kernel of the operating system and say, okay, tell me about the processor. Yep.
Why isn't the address size actually 32? Why is it a little bit more?
The processor itself supports up to 36 bits, which means, with this processor, it's good for, let's see, what is 16, it's good for up to 64 gigs of RAM.
Okay.
Yeah, the processor cannot handle any more than that. It's not that's a limitation of the processor, but you can have additional limitation due to the motherboard and other things too. All right. So that means, in Linux or in Unix, everything is a file or can be seen as a file, which is great because now you can write a program that can just read from /proc/something, and you don't need any special permission to do that. Okay, and you can ask for really important information about the kernel, how it is determining the clock frequency of the processors and stuff like that. And it's a very cool way of doing things. Right? Are there any questions at this point? Does anyone have any question about why I emphasize on command line stuff as opposed to clicking something and using the control panel to do something? No questions about that? Yep. You're not limited in any way. That is absolutely true. Okay, so yes, if you use control panel in Windows, it's easier. Okay, you can find something, you can just double click on it, you right click on it, you can find out what you can do with something, right? You look at the menu items and you know what you can do with something. You don't have to memorize all the commands, all the switches to all the commands. But what if you want to automate something? How do you automatically have the computer to click here, and then go over here and click something? Can't be done, right? But what about all the things that I do on the command line? If I can type it, I can save it into a file and then run that file as a batch file. Okay? So at the minimum, if I don't need any type of logic, if I don't need any variety, any variation of what I'm doing, I can just literally copy all the commands that I do into a file, into a script file, and just say, run this script. And that will save me a lot of time already if I'm doing something over and over again. But if you're doing it using a GUI, using a graphical user interface, you say, okay, I want to click here first, and then here, and then over here, and then over here. That process cannot be automated. So that's why command line programming, or the use of command line itself, is valuable. Okay, because most people look at it and go like, wow, this is something that people do 20 years ago. Well, guess what? They still do it today. People who need the efficiency, who need to automate stuff, still have to do it on the command line, or at least know how to do it on the command line in order to automate it. Is that making any sense to you guys? Sort of? Okay. All right, so we are moving on to the next program. Remember the previous Hello World program. This is another way to do exactly the same thing, okay? So this part talks about a file as far as this class is concerned at this point is nothing more than a stream, and a stream is really just a conveyor belt. Okay, it is a way to move something from one place to another place. Okay, that's basically what a stream is. So sometimes in my class I use lowercase s for stream, and other times I use uppercase s. So it depends on whether I use it as a class name or do I use it just in general as a stream of bytes. Okay, we'll talk about this later on. What is a class and how it is related to object-oriented programming. But at this point, we'll just go ahead and focus on the second program, which is the same thing as the previous program. It prints exactly the same thing, but this one is written in what we call the object-oriented way. The other one is just regular C. This one is C++. You can see that the include file is different. It is not standard I/O anymore. It is just I/O stream, input-output stream. And this one does not have an extension. It's not a typo. This is actually the way you spell out I/O stream as a header file name. This part here looks kind of odd. This is entirely missing in the previous program. Using namespace standard, STD is standard. So why do we have such a concept called a namespace? Okay, because it seems like it's just something that is unnecessarily complicating programming in C++. Well, as it turns out, there are certain names that are very common. Okay, something like convert. Okay, you will probably find convert as the name of a subroutine in many, many different contexts. So, which convert are we talking about? Okay, depends on the context, right? Are we talking about my convert or your convert? Yep.
Into that name first, and then you find out, oh, somebody has used this name already. It is possible that you have the same arguments also, right? You can convert from a string to a string, but what is the actual conversion? That becomes the lead. That's the question, right? Okay.
So namespace is here so that we can easily distinguish which convert are we talking about. Okay. So when I write my code, I would say, you know what, I'm going to declare my own namespace. Okay, so I have a text namespace. So all the subroutines, all the classes, all the definitions that I use will be falling into that particular namespace. So let's say that you are going to write your code, your own library, and you want to say that, okay, I don't want to have to think about whether a particular name is already used by another person. So what you do is you say, okay, I'm going to have my own namespace, and I will use any name that I want to, because I don't have to worry about my name is colliding with the same name that somebody else is already using. So that's the whole purpose of the concept of a namespace. Now, without using this line 3 here, because all the names within IO stream is in the standard namespace, I would have to use std : cout to replace just cout. I would have to use std : endline or endl in order to use nl. So it's not like impossible, but it is very cumbersome. Okay, so for stuff like this, because cout is fairly uncommon to be redefined by somebody else's namespace. So for stuff like this, we just say, if it is not found in the current context, use standard std as a default fallback as a namespace. Okay. So let's go ahead and try this one out. Okay, let's see if that works or not. So we're going to write a program called cout.cpp. And we still have to include IO stream here because the header file is still necessary. And then we'll go ahead and write the rest of the program without using namespace in this particular program. So I will use cout, but this time I have to say standard std : cout, because now without the default fallback, if I just say cout and cout is not defined within this program itself, the compiler will just complain and go like, okay, I don't know about cout. Okay, who has cout? Who defines cout? Nobody. But let's go ahead and do it without standard first. So we just say cout, go ahead and say hello world, and end of line, and return 0. So we want to compile this program just to see what the compiler has to say about it. So g++ dash warn all dash pedantic dash o cout.cpp. It complains about several things. So right here it complains cout was not declared in the scope, which is another way of saying, hey, I don't know about any cout. Okay. Well, that's because it is in the namespace. Okay, it's in the standard namespace. So there are two ways to fix this program. What I have written here in the notes here is a typical way of fixing that problem. But the other way to fix this problem is, if you don't mind typing a lot, you can always say, oh, it is cout of the standard namespace. It is end of line of the standard namespace. So if I do it this way, that should fix the problem. And the compiler doesn't complain anymore. So that one line, which is using namespace std, is basically us being lazy, me being lazy, and just say, if cout is not defined locally, try out the standard namespace and see if that namespace has this particular name defined. So that way, I don't have to keep typing std : all day long when there's really no danger of colliding or running into those names that IO stream is defining. All right. Are there any questions about namespace, why it is necessary and what it's for?
You said that you had if you explicitly specify to use the standard namespace standard combo cout, it would still check if there's a local declaration of cout.
That is correct. You can now have a local one as well as another one in the namespace. If you designate a particular namespace, you can now start to use cout from the standard namespace and cout from your namespace. They won't collide anymore, because you have now a differentiation between the cout of your namespace as opposed to the cout of the standard namespace. So that's another advantage of having namespaces, is we can now start to use the same name that belongs in different namespaces at the same time, because we can just say, okay, which namespace are we talking about? Oh, this particular one. Right. So the rest of this is really just explaining what I have just said. On line 1 is the header file. On line 3, we have the default fallback of a namespace. This is a link, long history of the name or the specification of the header file name. Why doesn't it have a extension of .h? There's a long history behind this. They used to be .h. All the header files must have an extension of .h, and then they say HPP for C++ files only, and then .h for C files only. And then later on, they decided, let's not even have an extension. Okay, so if you click on that link, it will give you an explanation of things that are not particularly relevant to this class, but nonetheless, it gives you an idea of what is the history of all of that stuff. Yep.
Say again? Well, how do you use that? Yeah. When you define the subroutine, you can just use the namespace name : and then the name of the subroutine. That automatically make that subroutine that has to be connected with namespace. I don't think there's a special way to declare, oh, this is a namespace. Just that can be a problem because the other convert must have a namespace declared for it already in order to use the namespace.
Yeah, no, I'm saying it's already.
Then you say the namespace.
Yeah.
Oh, : convert.
Yep. Oh, thank Thank you. So this is a long history of discussion of why we use the .h extension sometimes and why we don't use it other times. It's not important as far as programming is concerned. It's just a little bit of a history so that you know that it's somewhat arbitrary, okay, whether to use a .h or not to use a .h. Okay, see, this is the other part that I want to explain. End line or end of line is, why don't we use a backslash n here, just like with the other program? I mean, it worked in the other program, it will work here as well. Well, that is true. If I use a backslash n within the string hello world, it will still open up a new line and accomplish exactly the same thing. But the use of end line is special because it makes this program more platform independent. Now, what do I mean by platform independent? A text file is not a text file because it depends on which operating system you're talking about. In Linux, the end of line is represented by a single line feed character. In DOS, or in Windows, it is represented by a carriage return and a line feed character. In Mac OS X, it is represented by just the carriage return character. So if I just use backslash n and the compiler just blindly converts it to the line feed character, that conversion is not right on other platforms. Okay, it works okay in Linux, but it's not going to work in Windows. By using a variable name like end of line, now it can be platform dependent, because depending on which operating system you're using and depending on how it is linked, it knows what to pick up. If you're cross-compiling the program to run in Mac OS X, it automatically links end of line to both to just the carriage return character. So this approach makes it more portable across multiple operating systems, as opposed to the other approach, which is just converting backslash n to a line feed character. So that's basically the rest of this document here. Redirection and piping is not a concern here because it is not a language feature. It has nothing to do with C or C++. It is just a shell feature in Unix. And Windows can do it too. You can try the pipe symbol and also the redirection symbol. That works in Windows as well. Yep. Say again?
He said you answered his question.
Oh, I answered the question? Okay. All right, so the next slide talks about how do we print a value, the value of a variable in this case. So there's always the hard way and the easier way, but the hard way sometimes is the easier way later on. So there's no really absolute hard way or easy way to do something. So we'll go ahead and take a look at this one here. And this particular program, it's missing a return statement here. The compiler won't be happy. But this particular program is supposed to print 0 to 15 as in decimal and also in hexadecimal. Okay. In other words, if I want to write a program to print 0 to 15 in decimal and also in hexadecimal, this is one way to do it. Not the only way, but one way to do it. So what we want to do is to kind of take a closer look at this program and say, okay, but how does it get it done? Once again, the first line is to include the proper header file so that the rest of the program, or the compiler more like, knows how to use printf. Okay, so that's what the #include is about. The entry point of main as a subroutine. Okay, so that's good. And now we have the beginning of a for loop. And here, inside the for loop, I declare a local variable I and initialize it at the same time. And that's a perfectly okay syntax in C and C++, is you can combine the declaration, which is int I, with the initialization of the same variable. So as you declare, it will get an initial value of 0. Okay, that's okay. As long as I is less than 16, which is the condition to stay in the loop here, we will perform this step over and over again. At the end of each iteration, remember to add 1 to I, so I would go from 0 to 1, 1 to 2, and so on. By the time it goes from 15 to 16, this condition will fail and then it will get out of the loop. So those are not the focus of this particular discussion. The focus is, what is this line doing? How does it print I in base 10 and then in base 16? Well, printf stands for print format, okay, or formatted. So that means we have to specify the format of how to print something. For the most part, which is this part here, oops, yeah, for the most part, which is up to here, it is nothing special, okay? It's just a print exactly I space in space decimal spelled out space is space. So print all of that stuff just the way it is specified within the double quotes, okay? That part is not mysterious. What is mysterious, or what is interesting, is the notation of a percent symbol inside the format string. The percent symbol is telling printf and say, hey, whatever is following is just a placeholder, okay? It's just a placeholder. But it's not just any placeholder. This is a placeholder of an integer that is supposed to be printed in decimal. That's why there's a D here. Okay, the lowercase d means it's decimal. It's supposed to be a signed integer in base 10. Okay. After this, we have just a comma, which is going to be printed the way it is, and all the way up to here is nothing special. Also, okay, that's really just going to be printed the way it is specified. Comma I in hexadecimal is, and then the space. So all of that stuff is nothing special. But once again, we see the percent symbol right after this one, which is telling printf itself and say, hey, this is a placeholder again. Pay attention. And it's a placeholder for another integer, but instead of using %d, I use %x, which means to the printf subroutine, it means now print this value, this integer, in hexadecimal in base 16. In other words, we have two placeholders within the format string. This is one placeholder expecting an integer. This is another placeholder expecting another integer. Okay. Now, with all the placeholders, I better actually provide the values to put into the placeholders, right? That's why we have I and I after the format string. The first I goes to the first placeholder. The second I goes to the second placeholder. And that's why it will print the value of I first in decimal and then second in hexadecimal. That's how printf works. Now, is this difficult? Difficult? Well, kind of, because you have to know all the different ways of printing something. I am just using the very simple ones here, okay, just %d and %x. But you can make it, even just printing in decimal and in hexadecimal, you can make it somewhat complicated. In other words, in printing as a hexadecimal number, I can specify %08x to specify print all the leading zeros and use exactly 8 spaces or 8 characters to print out this particular integer. So I have some control over the actual formatting, not just the base, but the actual formatting of numbers. Okay. Well, how long would it take to learn about all of this stuff here? It's just a matter of looking up the right documentation and doing it, and writing your code accordingly. If you already have Linux installed, I know we're running out of time just about, you can do a man printf, and as a manual page, printf will show you the format that you can use. This is actually a command, but it follows the same format notation. So it will, maybe it doesn't show you everything. So let's see. I'm just looking at all the topics that may potentially show you formatted output conversion. So maybe 3 would do it. This 3 is basically chapter 3. This is the topic name. So I can do a man 3 printf. That would do it. So it shows you what type of format string you can specify here, and all the variations of that thing. I mean, I'm not going to go through this entire document. It is really long, and it talks about floating point numbers, strings, and and all the other stuff that you probably don't need to know at this point. But the point is, this has been done for a long time. Okay, I'm guessing this has been available since at least the late 70s, so it has been available for more than 40 years. Okay, so for 40 years, people have been using this kind of more or less the archaic way to specify how to print something, the formatting of numbers. And then C++ came along. C++ came along in the mid to late 80s. So when C++ came along, people say, let's make it easier. So the same thing can now be expressed like this using cout, using C++ or object-oriented programming. So you basically specify cout, which is the standard output file, and say, I want to print I in decimal is, and with a space, just the way it is as a string, and then make sure that we use decimal for the following thing. And the following thing is just I, and then what follows that is a comma, I in hexadecimal is, just literal string here. And then whatever follows, I want to print in hexadecimal. And what is that thing that I want to print in hexadecimal? It's just I itself again, and then end of line. So you compare these two approaches. This is the new way of doing things. This is the old way of doing things. The old way of doing things is actually more concise. But it does take time to learn about all the formatting options and all the different ways of doing it. That's how I learned C and C++ programming using the old way. The new way is actually, in some way, it is actually harder. Because once you switch the base of how to print a number, it is sticky. So if you don't specify otherwise, after this here, all the other numbers that you print will be in hexadecimal. Because it's sticky. Yeah, it is sticky. Which that part really bugs me. That it is sticky. Whereas in the previous one, nothing is sticky. You always have to re-specify everything, okay, of how you want to print something, which to me makes sense. There's no default. There's nothing that is that you take for granted. You have to specify everything, in order to print it right. So that's the end of today's class. This is the second class of the week already, so I'm happy and have a nice weekend. But work on your homework assignment, okay? Because you have one day to ask questions about it, which is next Monday. Okay. Well, you can come to my office and call me too. But in terms of class meetings, we have one class meeting to ask questions.
So, is it possible just for non-edification?